The first founder that we have is one that I've been able to work closely with, Kamel. He is the CEO and founder of FibrX. FibrX is transforming the way that we think about corrosion and structural risk, and he's going to dive into all the details there. But one of the kind of great things about Kamel, when I first saw his pitch, I thought, okay, here's an experienced founder. He knows how to build a company. So he's done this before. He's built something from the ground up. He's sold into government, which is incredibly relevant to what he's doing today. And then when I got to work with him, I saw that those skills in action. He was able to build a team around him. You'll see in his deck, he has an incredibly strong team working with him. He, inspired, this great group of people to build this with him. And he's got an advisory board with some of the top companies, in his industry that have rallied behind him, are working on his team and working on this problem with him. And because of that, over the course of the months that I've been working with him, he's been able to be relentlessly focused on building those relationships in these difficult industries. So I've seen him over the last couple months build relationships, close deals, launch pilots in oil and gas, in government, and with university partners, which is not a small feat. So, I'm really excited to, invite him to come and tell you more about what he's doing. Thanks a lot.
Hello, my name is Kamel Greene, founder and CEO of FibrX. I can distinctly remember my time working for the National Nuclear Security Administration. There was this continuous emphasis on wanting to understand the structural health of our critical infrastructure. This is because when critical infrastructure is not adequately monitored, it can prove disastrous, ultimately leading to the loss of life, supply chain issues, and national security vulnerabilities. Here at FibrX, we're building a real-time 24/7 continuous monitoring platform powered by AI as well as fiber optics as a sensor. This means the end user now can be able to see what's happening in real time at the microscopic level. We're a dual use application, so we're working within the public and private sector. So within the public sector, aerospace and defense, within the private sector is really leaning in from a nuclear as well as offshore wind, oil and gas standpoint. When looking at this problem, we identify three major issues. The first one being is inaccurate solutions. Right now, when trying to remedy or understand or detect what's happening from a structural corrosion standpoint, we've seen that most use cases are either visual inspection or LiDAR. Now, the problem with these solutions is that they're one, invasive, and then in addition to that, they're actually reactive. Secondly, we've seen that the troubling infrastructure is just a problem. So we know that the US has been first to a lot of different things, but right now we're seeing the ramifications of being first, and we need to fix that. And then lastly, it's too costly. This is a $2.3 trillion problem that's happening year over year. And then within the Department of Defense in particular, 20%, which is equivalent to $20 billion of their annual maintenance budget goes specifically to corrosion. We want to fix that. And so what is FibrX? So this is a three-pronged solution. So we have a software standpoint, which is our AI ML, as well as a hardware solution to that. And so what we're looking at is we are able to extend the lifespan of that critical infrastructure because what we're utilizing is fiber optics as a sensor. So now you're seeing things in real time. And so this now is predictive insights, predictive analytics. And so not only are you detecting the problem, but you're able to prevent the problem in the future as well. Now, when looking at our traction, one of the big things I like to set the record straight is that this solution is not some figment of my imagination. This is the real deal. So we have a working MVP. In addition to that, we also have an exclusive license with the US Navy. We're currently launched pilots within the oil and gas space right now as well. And then we also have a pending CRADA with NASA. One of the big things that I'm super excited about is the CIBR and CITR program was just reauthorized. And a lot of people don't know, so I like to say we were just awarded, which was our first application, we were just awarded a CIBR with the US Air Force as well. And so this is a problem that's needed, and we're effectively going to solve that as well. When looking at some of the big things, one big thing I like to denote, which I kind of got ahead, is moreover how the solution actually works in real time. And so right now, what you all can see right here is you all see the platform. So rather this is an oil and gas pipeline or offshore wind turbine, this is distributed fiber optics. And so this is not the traditional norm of a fiber optic. This fiber optics is monitoring two different data points. So it's a data point, it's a change in temperature as well as a change in pressure. And so we're able to apply that to the infrastructure itself, and it doesn't have to be on the full platform for it still to monitor areas in which the fiber optic is not adhesive to that platform. We're then able to analyze that data, and that's where our AI and ML is happening. We're setting delineations, understanding different baselines and thresholds, and then we're able to wirelessly send that to a dashboard. And so now you can imagine someone over oil and gas, nuclear, offshore wind, being able in real time to see from their mobile device or their tablet to see a dashboard and see a 3D rendering, a digital twin of what's going on. As I've talked to, these are some of the different traction points. I've talked about the license. I've talked about the different use cases as far as just closing with the Air Force. But one of the big things I like to denote as well is really our strategy in expediting ourselves from an R&D standpoint. And you can see that happening with different universities we're partnered with. This is a big market, and a lot of times people see the market size, right? Our total addressable market is 3.2 trillion, but this is unique because we're agnostic per se in so many different areas. However, in running our unit of economics, we filter it down based off where we want to focus on first. So again, public sector, aerospace and defense, private sector, more of oil and gas, offshore wind and nuclear, and then we'll scale accordingly. When looking at how we're going to scale, right now, our main goal is $1.2 million in annual recurring revenue by Q1 of next year. And how we're going to effectively do that is getting these SBIR and SITR opportunities as well as closing capital so that we can excel and really focus on speed. Right now, we're in that iterative process as far as our platform as a whole, but we're also working and having active customers and pilots that we know want and need this solution and are actively using it right now. How do we ultimately make money? One of the big things that I've learned in one, having a company already where we've sold to government, but also working within the federal government is I do know that when it comes to selling specifically to the government, the big thing you typically hear is the long sales cycle. We expedite that. And that is a platform as a service. So we have a software side and a hardware side, but our hardware components are off the shelf. And so we're able to move very quickly. And so how we can expedite that as well, as opposed to having this heavy lump sum that requires so much allocated money years ahead, we can move quicker because we know that this is going to be a multi-annual contract. So we'll ultimately get that money as well. Here's our team. Again, I mentioned before, I'm a two-time venture-backed founder, have experience in working for different laboratories as well as within national security, but also having a company where I was able to learn how to adequately position a company that works in that sells to private and public. But in addition to that, our chief technology officer is currently a professor at Ohio State University and really a world-renowned professor when it comes to structural degradation and corrosion. And then Michael Kupels, who has a wealth of knowledge, who's our systems engineer as well as our AI and ML engineer working for NASA, Raytheon, as well as Boeing. Here's our advisory board really set to focus to help us in areas in which we don't necessarily know, say, guide us in Department of State as well as within marketing and venture capital. And then right now we're actively raising a $1 million round, and we currently have 50% of that secured. I'm excited to answer any questions that you all might have. Thank you.
Great job, Kamel. Now we'll open it up to one or two questions.
There we go.
Are there additional sensor types you're going to be adding? So you said you had temperature and pressure, but I know that that's not really the game changer when it comes to degradation of metals.
So that is the game changer. So the fiber optic is the sensor itself, and that fiber optic sensor is measuring two data points. That's a change in temperature and pressure. When that fiber optic is adhesive or epoxy to the platform itself, whenever there's some type of change in temperature or pressure, it's going to indicate press on that sensor, and then that's where we're able to send those data points. And our AI and machine learning process is able to set thresholds and baseline and delineate accordingly. So that is the unique sauce to that solution.
Okay, but are there any other sensor types that you would add to the network?
Not necessarily. I mean, if you want to beef it up, you can add certain sensors that are checking temperature in itself. But the uniqueness around our sensor is that it's non-invasive, so you won't see it. And so those two data points is what you need to rectify that problem. Okay. And so that's what we're using right now.
Thank you.
Yep.
Thank you. One more question.
Somebody got a question.
Okay, no problem. One more round of applause for Kamel. Thank you.
I appreciate that.